Good evening. Well, Mars is still very much in the news, and clearly that's going to be our main theme this evening, and we have some amazing pictures to show you. But first of all, an interesting news note. NASA's Stardust probe had been by a short period comet, Comet Wild 2, and sent back the best ever pictures of a comet nucleus. I think you'd agree, these are really very fine indeed. And now, on to Mars. A pity about Beagle too, but the two American landers, Spirit and Opportunity, have come down safely. Spirit in a large crater, Gusev, once possibly an ancient lake, and Opportunity on the other side of Mars in the Meridiana area. And both those are now sending back results. And the Mars Express probe is sending back stunning pictures, so a great deal is happening there. And with me now, let me welcome our three guests. Professor Gary Hunt, involved in all the early Mars probes, Dr. Andrew Coates with Mars Express, and geologist Peter Cattermole. So we're delighted to have you with us. First of all, Gary, these two probes, Spirit and Opportunity, they differ from all the earlier missions.
Quite stunningly different. They're very large. They're mobile laboratories. And I think the important thing is that they safely landed. That's the first thing, which is no mean accomplishment. And after a period of 6 days of various tests, we can now get on and start to carry out a whole range of geological experiments to analyse the soils and the rocks nearby. Not being without problems. The Spirit had an initial problem with its computer memory. Opportunity's had a recent problem with an onboard heater. Both of these have been overcome, but we now are well online to make some significant discoveries and analyses over the next 90 days.
Why 90 days only?
Well, that's the time period of which they will be able to get enough energy from the sun to power up their batteries. They require 140 watts while they're on the surface. These batteries will drive the instruments, and after about 90 days there won't be enough sunlight reaching them to keep these solar-driven instruments going.
No trouble so far with Mars Express. Working well. What's the latest news?
Yes, absolutely fantastic mission. It's sending back wonderful data, and certainly the images and movies which are coming from the camera on Mars Express show some wonderful sights. There's also signs of water. Water has been seen towards the South Pole at Mars for the first time. This is the first time that the sort of spectral signature of water has been seen in that location at this time of year.
We've known for a long time that the polar caps were mainly water ice, haven't we?
We've known, certainly, we've been able to see it at the North Pole, and also signs of water, in fact looking at hydrogen, that was discovered by the Mars Odyssey spacecraft, and that actually mapped the whole surface of Mars within 1 metre of the surface, and showed where the water was likely to be, but in fact what it was measuring was hydrogen. But Mars Express now has seen the spectral signature of water ice at the South Pole. And we can see with these pictures, the first one here shows the visible view that you would get from the Omega camera, showing the South Polar Cap. Then if you look at that in the light of carbon dioxide, we see a different picture. And then the third one shows water. So this is the discovery of actually water at the South Polar Cap of Mars. It's also seen water vapour in the atmosphere, and it's seen water escaping to space, because Mars does not have a magnetic field anymore, and it loses its atmosphere that way.
Well, Peter, you're the planetary geologist, and Mars is certainly providing you with a good deal of information.
Well, Mars, of course, is always exciting. I always get excited when there's a space probe going near Mars, because Mars always comes up with the unexpected.
It does.
And as we've heard from Andrew and Gary, we have learnt something about the presence of actual water on Mars for the first time. We've had a probe land in an impact crater, giving a chance to see some solid rock, really, for the first time. And we've got all sorts of interesting minerals, which we've now got a handle on, which will enable us to build, I hope, a better picture of how Mars has evolved.
What is the surface like?
Well, as you know, Mars is called the Red Planet, and that is very aptly named because there is a lot of iron oxide at the surface. But the actual state of the surface, the actual oxide layer, is obviously different from place to place, because when the airbag of one of the lander probes scraped that surface, it very clearly showed it was almost as fine as talcum powder. So although we think of Mars as a red desert, and we perhaps equate it with the red deserts of Utah and California, there's no sand on Mars, because sand comes from the mineral quartz, which forms from the Earth's continents. Mars doesn't have continents. So the sand, in quotes, of Mars is probably dust, and huge areas of Mars are actually covered in dust, and it blankets the volcanic rocks, the impact breccias over large areas. And the problems that we've had until these probes got there is to see beneath this red layer of oxide.
Well, both the landing sites were very carefully chosen from geological point of view.
Yes, Patrick. The Gusev crater site is interesting because we believe an ancient lake ponded in the crater of Gusev many hundreds of millions of years ago, so we should be able to find sedimentary rocks in that crater if we're lucky. The second site is in an area of the highlands where previous missions have discovered the mineral hematite, which is an iron oxide, a grey version of hematite, measured in large quantity for the first time. And hematite can form, one way it can form at least, is in the presence of water. So there is a possibility it's been precipitated in a lake or from water in some measure.
What about the rocks? You've got some rocks there. These obviously are terrestrial rocks. Are they, do you think, like the rocks we're going to find on Mars?
Well, yes, I wish they were Martian, Patrick. This is a piece of Yorkshire, actually, which is almost the same temperature as Mars at the moment. This is a piece of sandstone that's made of quartz. Now, we're not going to find quartz on Mars, but it is a fragmental rock, and in this section, which you see on the screen now, you can see that the little quartz grains are held together by a cement of other material, and it could be that the instrumentation, the high-resolution camera, if it gets close enough, will be able to see the fragments and the cement that's holding it together. Now, as I say, on Mars there is no quartz, and if there were ancient rivers on Mars we wouldn't find sedimentary rocks made from sandstone. They're more likely to be made from much finer fragments of oxidized clay, because the Martian subcrust is by and large made of igneous rocks such as this basalt. This isn't a piece of Martian basalt, but a basalt is a basalt is a basalt, Patrick, whether it's on Mercury, Venus, Mars or the Earth. And a lot of the red dust that we see on Mars is simply the broken down and oxidized residue of the breakdown of the ancient basaltic crust of Mars. And you've also heard that one of the sites we're going to, the Opportunity site, is in an area where the multispectral probes discovered a lot of hematite, a grey iron oxide. This is probably somewhat richer in hematite than the layer we see on Mars, and it'll be interesting to see if this is related to the movement of water or whether it has an igneous origin. And then finally, we have discovered the mineral olivine on Mars some time ago, and this is the mineral olivine. The presence of olivine, which originates in basaltic rocks. If olivine exists on the surface, it suggests it hasn't interacted with water, because olivine is a very high temperature mineral. It hates being around in the presence of water. If there's olivine on Mars, that olivine cannot have been sitting in water for a very lengthy period.
Of course, Mars Express can survey the entire areas, and that will tell us a great deal.
Well, Mars Express is in an orbit which takes it 8 hours to get around the planet, and over the 2 years of the mission it's going to be building up a complete picture of the surface, because the actual orbital plane changes during the mission. It's 1 Martian year or 2 Earth years. So it builds up a complete picture of the surface, and there have been some absolutely wonderful views. There was one of Valles Marineris and the structures within that, which are to do with erosion. And of course, with the water on Mars, there can't be liquid water on the surface of Mars now, because the pressure in the atmosphere is too low and the temperature is too low. So the ice that Mars Express has been seeing is in the solid and the vaporous state. And,
but is there liquid water underneath?
Well, that's an excellent question, and of course the missions will be trying to look for that. And in fact, Mars Express has another instrument on it, which is MARSIS, which is a subsurface sounding radar, and that will be turning on in April, and that actually is able to look up to 5 kilometres underneath the surface. Bear in mind, so far with Mars Odyssey, we've seen 1 metre under the surface, and now this is 5,000 times that. So it's going to actually see where there is any water underneath. So Mars Express in general is looking at the whole story of water, from underneath the surface, through the atmosphere, and then the escape to space, because the whole question with the Martian water is, where has it gone? We know it was there 3.8 billion years ago, when Mars had a magnetic field, but since then it's been lost. So some of it has probably gone underground. We've seen perhaps perhaps the tip of the iceberg with Mars Odyssey, and some of it is escaping to space, and we'll be looking at that with the Aspera instrument.
Can you visualise Martian ocean?
Well, I think the other thing to add to that, I think, which actually links up to some of the things that Peter was saying, that the picture you can see of the caldera of the volcano, which Mars Express's image so beautifully, and we're talking about amazing resolution. We're talking about 12-metre resolution now.
Yes,
you think we used to be happy with a kilometre once, but you can actually see some dust coming in over the edge. Now this is adding to the other point that Peter was making. Everything transports so easily. This fine material moves around. It's a danger to the landers, but also it's meaning that material is broken up, moved around all the time, and can so easily hide what actually is the true surface is about. And that's why it's so important to have these remote sensing instruments that actually will probe just a few metres of the surface and tell us more about what's going on.
Well, you mentioned volcanoes, and certainly there were huge volcanoes there. I mean, Mount Olympus, 3 times the height of our Everest. Are they dead, or can there be any activity going on? Peter, what do you think on that one?
I would be very surprised if there's any current activity, frankly. Mars is, remember, only half the size of the Earth. It would have lost its heat much more quickly. And there is a lot of argument as to how young Olympus Mons is. Some people have suggested, stuck their neck out and say 100,000 years is the least. I think that's very unlikely. I would suspect volcanism ceased hundreds of millions of years ago. I'd be surprised to see anything happening today, which doesn't mean that there isn't escape of vapour from beneath the surface of Mars, but that's a different issue. Hydrothermal activity could still be taking place. There may well be trapped radioactive elements that are generating a certain amount of heat, but that's not quite the same as true volcanism.
Well, there were always several perplexing pictures during Viking which suggested clouds were being formed around it. We can never be quite sure if they were being affected by the volcanoes as a barrier, or well, due to material being vented out. But also the other point which intrigues me, which Peter may be able to throw some light on, you look at the picture that's come back from Mars Express. It's 3 kilometres deep. Very strange, deep caldera structure on quite a strange shaped object anyhow. This is quite peculiar when you compare it to the features we're seeing on the Earth.
It's odd, actually. It's funny. I did a very timely visit to the summit of Etna towards the end of last year, and there's a crater at the top of Etna called the Bocca Nova, which is usually full up to the top with lava, and it happens to have drained itself away, and it looks like a much smaller version of that huge. It's like somebody's taken a cork out of a top of a bottle.
Well, Mars Express is sending back amazingly detailed pictures. Just in passing, any chance of seeing a Beagle too, do you think?
Well, with the very good resolution camera, the part of the high-resolution stereo camera which can look at 2-metre resolution, there is a chance of actually doing that. The trouble is it's a bit like looking for a needle in a haystack, because it's such good resolution you have to take a lot of images, and we don't know exactly where Beagle is, and so actually pointing it in the right direction or having it at the right point would be a matter of luck. But the Mars Global Surveyor camera did see the Spirit lander on the surface of Mars, but of course they know where that is. But the trouble with Beagle is at the moment we don't know where it is, but there is a chance of seeing it either via the cameras or perhaps by looking at the methane from the airbag, so that is going to be looked at as well.
It's very sad. I always say that, of course, Colin Pillager did everything he could. I always say, for this kind of thing, you need 2 things. You need skill, you need luck. He had the skill. This time, I'm afraid, he didn't have the luck. I wonder what happened.
Well, I think also it's worth adding that the Americans did have the skilled engineers, and they had a little bit of luck as well to overcome it. The second lander opportunity absolutely landed spotlessly, in right position, right itself immediately, and they've overcome their onboard problems. And you do need an extra bit of luck.
I'm sure you're right. Well, all right, then now, life on Mars. No little green men, no Llewellyn canals, but is there any life at all? So far, we don't know. So, Gary, what's your guess?
Well, I've never been one who supports life in that absolute sense. I think we're going to find some tantalising information about the early structure of it, but in terms of life forms, I'm not terribly taken up by it at the moment. I just want to actually see some advancement understanding the basic geology. I'm not convinced there is it yet.
But has there ever been life there, do you think, Peter?
If I had to be a gambling man, I would say no. And the reason for that is I think Mars is too small and it cooled too fast. That's my feeling, and I think even if life did start, it would have been snuffed out very quickly. I have a feeling that Earth is unique in that respect in our solar system. Yeah, yeah.
Not in the galaxy. I mean, 100,000 million stars in our galaxy.
That's a different issue.
Many with planets, a different thing.
That's a different story.
Yes.
But 3.8 billion years ago, everything was so different on Mars. You know, it was a much more exciting place with water flowing on the surface, the magnetic field there to protect life, you know, possibly on the surface there, and the volcanism going, all that sort of thing. So wildly different compared to now.
But
So that's the time that
But it
the
wouldn't
people
have
are
lasted
interested
long
in.
because it is small enough because things are moving so fast. The question is what's the smallest amount of time an atmosphere can stay there in order that life can be maintained?
Yeah.
I think that's the interesting question.
Yeah.
I suppose we'll know for certain when we get rocks that we know come from Mars and look at them, see if there's any trace of either present or past life there. And I wonder when that's going to be. When are we going to get a sample and return probe, I wonder?
Well, difficult to say. I mean, the European Space Agency's Aurora program would like to do that. NASA also have plans along that line. But in fact, before we do that, it's possible to send probes to the surface of Mars and do analysis in situ. And of course, that's what we wanted to do with Beagle, to actually look for the signs of life to do with carbon-12 and carbon-13, one of which life uses, the other it doesn't. And so to repeat that sort of mission and actually do investigations in situ on the surface of Mars, I think that is worth doing again because nobody's doing it. I mean, Mars Express is looking at the story of water on Mars, the Spirit and Opportunity looking at the geology, looking at the water, the signs of water having affected the geology in the past, but they're not actually looking for life. And what we really want to do is look for the presence of life there, and of course that's why we want a Beagle 2, Beagle 3 and other missions to go ahead and look for life. It's a big question.
What we actually have shown so far, Patrick, is we've shown that we can get some pretty sophisticated instruments down onto the surface of Mars, which is no mean feat. I think the US has shown that. We've also shown that we can construct some amazing instruments to analyse material there, and we've also demonstrated some mobility. If we integrate all that together, then we can move around Mars a bit more with more instruments, and then I think we will then know where we should be sending the material back from to do the sample return.
NASA certainly have a whole range of missions planned. A little while ago, I talked to Dr. Dave Lavery of NASA. Dr. Lavery, welcome to the Sky at Night. And first of all, congratulations upon the 2 rovers.
Thank you, Sir Patrick. It's great to be here from the Jet Propulsion Lab.
What about future missions? One, of course, is Project Phoenix.
Phoenix is a mission that will be flying in 2007, be going near the North Pole of Mars, and really trying to understand, again, our strategy of trying to follow the water, trying to understand the water history of Mars, but also going a step beyond the sort of investigations we're doing in these rovers to also start looking at the habitability of Mars. What is it about Mars that may make it a place that's conducive to life? Some of the things we're looking at for future robotic systems that we may fly to Mars include things like very, very long-distance, long-lived rovers. Rovers that rather than last a few months may last several years. Rather than traveling a kilometer or two, may go tens, potentially in long-term, even hundreds of kilometers. And then we do start looking at, well, what do you do once you get off the surface? Can you actually have robotic aircraft? Mars has an atmosphere. Maybe we can look at robotic aircraft. We can also go the other direction. What about a robotic system that can actually drill down into the crust, into the subsurface, and explore underneath the surface of Mars? And all these things are very achievable, very realistic, and what we're really trying to do is figure out, given our strategy of science, which ones do we want to do next?
Sample and return missions are also under discussion.
The science instruments that we fly to the planets on these missions, such as Spirit and Opportunity, Phoenix, and the MSL mission, just because of the nature of developing flight hardware, they tend to be instruments that are very, very advanced in terms of spacecraft. But in comparison to a type of instrument you may have in a well-equipped laboratory on Earth, they're a generation or two behind. It's sort of like computers, that they're advancing so fast, and your desktop computer is now much more powerful than the one that was in an airplane that was built 10 years ago. What we'd like to do is sort of take advantage of that fact by, rather than having to rely on an instrument that may be 2 generations old sitting on the surface of Mars to do analysis, if we can grab the sample, bring it back to Earth, we can then study it with the most advanced instruments of the day. But even better, if a new instrument is developed tomorrow, that sample is still there. We can take it over to the new instrument and do a whole new sequence of studies rather than having to fly another mission to Mars.
What about long-term plans, such as manned exploration?
One of the things that we're trying to understand right now is what the potential for the manned mission will be and when it might happen. The goals that the President has recently laid out basically said, in effect, that we're looking at a return to the moon no later than 2020, potentially several years earlier. That's the one hard date that we have right now. What we have said and what the President has laid out for us is the goal to say, once we are there and we are back and we've established ourselves on the moon, the next step is to go to Mars. But we haven't put a date on it yet. And until we do some more study and some more analysis about the technologies required, the finances required realistically, the political support for it, and how we want to develop a solar system exploration strategy by humans, it's difficult to put a date to say this is when we're going to Mars with people right now. One of the big issues we have to do is, can we invest in technology development to make those things cheaper? Can we make the actual cost of putting a kilogram from the surface of the Earth up into orbit and then into Mars much more affordable? That's one of the fundamental issues that has to be addressed. How do you handle these life support needs for a mission that may go on for 3 years? How do you protect the humans from the radiation environment during the cruise phase or even once they're down on the surface of Mars? Can we guarantee that the Martian environment itself is not toxic? These are all questions that we have to answer and technologies we have to develop, but once we get those addressed, are we then hopefully well prepared for the human mission to Mars? Well, that's what we're out to find out.
What do you think a manned mission could do that a robot can't?
I think one of the things that a human mission to Mars can do is react to new information, new environments, changes in the systems, and understanding by looking at something and saying, oh, this is something I didn't expect, that I wasn't prepared to address, but I as a human am flexible enough that I can react to that and I can change my plans and I can go and now study this in a new, different way. Okay, that's a very pragmatic answer about how a human mission would be different than a robotic mission. But also there's the more emotional answer, which is a human can stand there on the surface of Mars with their own human eyes rather than a pair of robotic cameras and gain a whole new understanding of what it's like to truly be on a different planet and express that back to the population of the entire world in a way that a robot, as good as they are, never can do. And that's a big part of the sort of emotional need to go and explore, to understand, to see what's new and find out what's over the next hill.
Dr. Avery, congratulations again, and thank you very much.
Thank you.
Interesting comments, Gary.
I think it's exciting to hear NASA's views on the future of Mars, the fact they're accelerating their missions, and they're planning a program for the next several decades. We should be excited by that prospect.
Let's look forward now, can we, to the fairly immediate future. We have probes going around Mars, probes on Mars, finding out more. What do you expect in the next few months, Peter?
I expect us to get our first handle on the serious bedrock. I think that Opportunity is going to get to the wall of that, where you see those rocks in the far distance of that lovely panorama. I think we're going to get some samples of serious bedrock in the boulders as well, and I think we're going to possibly establish that there are some sedimentary materials on Mars, and that's something that really excites me, because it implies water.
Would you agree on that one?
I'm looking forward to the Mars Express results, looking underneath the surface, looking up to 5 kilometres underneath the surface, seeing where that water is, seeing how much there is, seeing how much is escaping into space, and we've got to build up a few months of data to do that. And so within the next few months we should be getting the whole story of water on Mars. Fantastic.
I think the point I would say is the fact that we've been able to get 2 robots down and they're working and we're making progress. This is the most significant thing of all. It says we have a future. The future of the things we've got to do on Mars is we've got to go other places. We've got to be able to move around. And the fact that we've got these engineering robots working and we've repaired their problems and we're learning new scientific facts, I think it's incredibly fundamental and really exciting.
And I'm going to butt in and have my 4th chip of the day.
I'm sorry I cut you off.
The other thing that I think is really exciting, I'm sure all of us would agree, is the fact that we actually have 3 orbiting spacecraft and 2 landers producing material at the same time. This is going to push things forward tremendously quickly, in my view, and it's the first time we've ever had so much information coming of a different kind.
Yes, to have 5 spacecraft either in orbit or actually measuring on the surface, it is a golden age of Martian exploration at the moment, for sure. There's a lot of things to be done.
We'll probably end up with more questions than we have actually got answers.
I'm sure we will.
So we've really got to start working where to go forth. There's some very fundamental things there to be dealt with. So I think the next few decades are going to be pretty good as we can now focus, and hopefully, I'm sure about Andrew and Peter would like to see, we have a programme of missions rather than diving in and diving out, which I think has been the mistake over the last few years.
Exploration on Mars is fascinating and important and teaching us a great deal. Gary, Andrew, Peter, thank you very much.
Thank you.
When I come back next month, I'll be talking to Professor David Southwood, Director of Science at ESA. Until then, from all of us, good night.